Good afternoon, viewers. Welcome back to Easy Mathematics. We thank God today is Friday and another day, a very special one, of course. Last week we started with vectors and we want to conclude it so that we'll be able to look at the next subject and solve past questions for those of us going to write our final exams. Today we want to look at the next topic in vectors, which is resultant. We'll look at equivalent, then how to multiply a vector by a scalar. Then we'll end it here for vectors. We'll continue the next time so that we'll look at the construction as well. Now with the resultant, as we say, when we say resultant vectors or resultant of vectors, it simply means the result we are going to get after either adding or subtracting. But here we deal with the addition of the vectors. So let's say we have a vector AB, the vector AB plus the vector BC. Now this is giving us vector AB. So we say the vector AC, the vector AC is a resultant vector. That is what we had after adding or putting the two vectors together. So we call this vector a resultant vector. So how can we calculate for a resultant vector? Now when you have to calculate for the resultant vector, when you look carefully of these vectors, when we started, you were told that this means we are from A going to B and we are from B going to C. So in any vector, we say that the second point of the vector, always note this, the second point of the first vector becomes the first point for the second vector. The second point of the first vector is the first point of the second vector. And that gives you the result when you put them together. So in terms of triangle, we can have this as our triangle, and the vertices we have here A, B, C. So from this vector AB, which means we are from A going to B, so we have the arrow this way. Then we have here BC, which means we are from B going to C. So this is BC. Then we have AC as the resultant vector. So AC. Since it is a resultant vector, we will double the arrows. So what this simply means is that we are from A. Our aim is to get to C. I can go straight forward from A to C, which is the resultant vector. I can also choose to move from A to B, and when I get to B, I'll continue the journey to C. So for me to move straight forward here is the same as me adding the distance here, which is the vector here, plus the vector here, which at the end of the day, I am going to arrive at the same destination. So that is all about the resultant vectors. Let's take questions and look at how we can solve questions with the result under resultant vector. So we have a question here which says that if vector PQ is equal to -1, 3 and QR is equal to -5, -8, find vector PR. So it means this vector PR becomes the resultant vector. So how can I therefore know the statement for the resultant vector? Now the first given vector here is vector PQ. So always we concentrate on the first given vector. So this first given vector is PQ. So the vector PQ plus, when we started, I told you that the second point of the first vector, the second point, so this is PQ. So the second point or the second letter of the first vector becomes our first letter or our first point for the second vector. So we have here PQ. So our next vector, we have Q. then R, because you can see they are dealing with P, Q, and R. So this becomes vector QR. And this is equal to the resultant PR. So you will notice that the resultant is the first letter of the first vector, and the second letter of the second vector, and that is the resultant. So in terms of triangle, we have this way. We have the point the point PQR, which means this vector, we are from P going towards Q. So the arrow is towards Q. And here we are from Q going to R. The arrow is towards R. Then PR, which is the resultant. So we double the arrows, showing that this is the resultant vector. So to calculate the resultant vector, we are going to use the one given here, which we have been able to state that vector PQ plus vector QR is equal to vector PR, which is what we have to find. So from the question, if PQ, which is the vector, is negative 1, 3, so we are just going to substitute that vector with it. So we have here as PQ, the vector given is negative 1, 3, plus QR. QR, from the question we have it. So QR from the question is negative 5, negative 8. So we have here negative 5, negative 8. So if we put this together, whatever we get becomes that of PR. So let's do the addition and see. Negative 1 plus negative 1 will give you negative 6. Then 3 plus negative 8. When this meet, it gives you a negative. So 3 plus negative 8 is the same as 3 minus 8, which will give you negative 5. So this vector is the vector PR. So therefore, the vector PR is equal to negative 6, negative 5. And that is how we calculate for the resultant vector. Always the second point of the first vector is the first letter or the first point for the second vector. So when you come to the number 2, it says that given that vector AB is equal to negative 1, negative 3. So the first vector that they've given us is AB. So we are going to say vector AB plus the second point here, which is B, then C. Why is it C? You will notice that we have ABC. So they are dealing with this triangle ABC. So the first point, the second point is the first point for the second vector. And this is equal to the vector AC. So if I draw a triangle for this vector, I'm going to get this as point A, B, and C. From the first question, we have AB, so we are going to A. Then we have BC, we are going to B, then C. So we have AC as the resultant vector. Good. So with this, we are using this to find for vector AC. So we said vector AB plus vector BC is equal to vector AC. Good. Sorry for that. So we have this, and we are going to find for AC. So from the question, we have AB as negative 1, negative 3. And we have BC, which is this, as negative 2, 4. So we just substitute. So what do we have for AB? We have negative 1, negative 3. Plus BC, what do we have? We have negative 2, 4. So if we sum these two together, it gives us vector AC. So negative 1 plus negative 2, what do we get there? you get negative 3. Then negative 3 plus 4. Negative 3, you owe positive 4, you have. You will settle, you have 1 as our answer. So vector AC, which is what the question is asking to find, vector AC is equal to negative 3, 1. And this is the answer for number 2. Vector AC is negative 1, 3. Negative 3, 1. And we have the last one under the resultant vector. It says that if vector xy is negative 2, 5. So the first vector given us is negative 2, 5. And vector zy is equal to 3, 2. Vector zy is equal to 3, 2. The question is asking us to find the resultant vector xz. So what is the first vector given? The first vector given from the question is xy. So with the first vector here, look at the point that you have at the end of the first vector. It is y. So this plus y with the vector z, because they are dealing with x, y, z. So the second point of the first vector is the first point for the second vector. Always note this, that the second point of the first vector is the first point for the second vector. So this plus this gives you the resultant vector xz. And the resultant, it is the first letter and the last letter in the second vector. So with this, we have vector xy plus vector yz is equal to vector xz. Now let's look at the question and see if we have this vector, if we also have this. We are finding for this. So from the question, we have xy as negative 2, 5. But here we have zy instead of what? Yz. So what do? We are going to find vector yz using the negative vector or the inverse vector. So let's calculate for vector yz. Vector yz can be calculated as the negative of vector zy. When we were taught vectors, we were told that if you are to find the inverse, you just negate the other vector. So what is the vector for zy? 2, 3, 2. So vector yz is equal to negative 3, 2. So this will give me yz is equal to negative 3, negative 2. So let me rewrite this expression again by saying vector xy plus vector yz is equal to vector xz. This expression, is what I've written as this. So from the question, we have this as negative 2, 5. From the question, we don't have yz, but they gave us zy. So we use the zy to calculate the yz, which is the inverse. So what do we have for xy? From the question, we have negative 2, 5 plus yz. When we calculated, we have negative 3, negative 2. And if you put this together, gives you xz. So now, negative 2 plus negative 3 will give you negative 5. Then 5 plus negative 2 will give you 3. So therefore, what we have been asked to calculate is equal to negative 5, 3. And this is all about resultant vectors. Let's go to equality of vectors. With the equality of vectors, as the name goes, equal or equal vectors, it means the two angles are equal. Now, when two angles are equal, then it means the magnitude and the directions are also equal. So if I have a vector, let's say vector A as x1, y1, and B as y2, x2, y2, if A and B are equal, it also means that their magnitude are also equal. So vector A is also equal to vector B, which means this x component is the same as this x component. So the value for this and this are the same. So you just equate them and go. So we have here, if A is equal to this and B is equal to this, find x and y if, let's say, A and B are equal vectors. So if A and B are equal, how can we solve for x and how can we solve for y? Remember that the components of the x and the x here, they are the same because they are equal vectors. So A vectors are x1, y1, which is equal to B. B vectors are x2, y2. So this value, you equate it to this. So x1 is equal to x2. The same thing, y1 is equal to y1. Then we say the two vectors are equal. So if these vectors, let's say if A and B are equal, if they are equal, we have to calculate for x and y. So since A is equal to B, then it means this vector and this vector are equivalent or equal. So what is the vector for A? 3x plus 1 and 2y plus 3. And this vector, it is equal to B. What is B? Negative 8, 5. From the explanation here, the x1 component is equal to the x2 component. So this x for the vector A is the same as this x for the vector B. So we are going to equate them to find the unknown. So we are going to say 3x plus 1, which is the x component for A, is equal to the x component of B, negative 8. So we tackle them this way and take it also this way with the equal to sign between. So here, this gives us a fraction where you have to solve, gives us an equation where you have to solve for the unknown. So we group like them by saying 3x is equal to negative 8, then the plus 1 will cross, giving you negative 1. So this is 3x is equal to negative 9. We need x, so what do? We divide both sides by 3. Divide by 3. X will cancel, 3 will cancel 3. 3 here 1, 3 here 3. So x is equal to negative 3. Then you do the same because you have to find for x and you find for y. So now that we have x, we solve for y. So this y component is equivalent to this y component. So we are going to say 2y plus 3 good. So we also equated y and y. Then the equal sign is still there. So we want y. What do? You group like terms because we have been taught equations in our previous video. So grouping like terms, we are going to get 2y is equal to 5 minus 3. So 2y is equal to 5 minus 3 is 2. I want y to stand alone. So divide both sides by 2. So 2 will cancel out 2 here 1, 2 here 1. Y is equal to 1. And so the question is find the value of x and y. So therefore, x is equal to negative 3 and y is equal to 1. They are not vectors, so you are not going to write negative 3, 1. No. X is negative 3, y is 1. And we call this equivalent vectors or equal vectors. Then we have the 2. Given that x is equal to this and t is equal to this. Calculate for x and y if, let's say, vector s is equal to vector t. So the question will tell you if they are equal or not. So since these two vectors are equal, it means the vector s is equal to the vector t. What do we have at vector s? We have the exponent as 5 minus x and the y component as y plus 3. So this vector is equivalent to t, and t is negative 6, negative 6. We were told that if vectors are equal, then it means the x component also corresponds, or they are also equal. So I'm going to say that the x here, which is 5 minus x, is equal to negative 6, which is the x component there. Then what do? We group like things. You can choose to take the x so that the 6 will come, or you take the 5 away. So if I want to take the 5 away, the sign in front of the 5 is positive. So this will be negative x is equal to negative 6. Positive crosses negative 5. Now I'm having negative x is equal to negative 11. I want x, not negative x. So divide both sides by negative 1 so that we can get rid of the negative. So we are going to say negative x is equal to negative 11, divide by negative, divide by negative. Negative will cancel negative. Also here, x is equal to 11 for the first one. Then you do also for the y component to get the y value. We have the y value here as y plus 3, which is equal to negative 6. So let's come here and say y plus 3 is equal to negative 6. We group like things. Send this away. Y is equal to negative 6 minus 3, because when the positive crosses is negative. So y is equal to negative 9. You owe 6, you owe 3. If you put them together, you owe 9. So therefore, our x value is 11, and that of the y is negative 9. And that is the way we solve for the equal or equality of vectors. Then with the last one, we have multiplication of a vector by a scalar. The scalar is represented as k. And let's say if you have the vector a, and a is xy, and you have to find the scalar by k, which is multiply the vector a by k. So we have k as our vector, as our scalar, then the vector a is x and y. Since we have to multiply, this value, which is the scalar, will multiply each of the elements in the vector. So this will multiply this, giving you kx, then this will give you ky, or xk and yk. So alphabetically ordered, you can say xk and xyk. So with the scalar, it multiplies each of the elements in the vector. So we have the first question here. Given that vector AB is equal to negative 3, 2, find 3AB, 3 vector AB. So the 3 here is the scalar, which is k, and you are using to multiply the vector. So we have to find 3 vector AB. So the 3 is the scalar, which is multiplying AB. What is AB? Negative 3, 2. So this 3 will multiply each of the elements in the vector, not bracket, in the vector. So 3 times negative 3 will give me negative 9, because 3, 3, 9. Positive times negative is negative. Then 3 times 2 is 6. So I have this as my vector. So 3AB is equal to this. So we can conclude and say, therefore, 3AB or vector 3AB or 3 vector AB is equal to negative 9, 6. And that is how we do the multiplication of a vector by a scalar. Then we have here, given or if A is this, B is this, calculate 3a plus 2b. This is like addition of vectors with a scalar. So first deal with the multiplication, then you add. So a is 3 negative 1, and we have a scalar of 3. So we are going to say 3 with the vector a, 3 negative 1, plus 2 with the vector b, b is 0, 6. So each of the element or the component in the vector will be multiplied by the scalar. So 3, 3, 9. 3 times negative 1, negative 3. Plus 2 times this is 0. 2 times this is 12. Then you add, which is addition of vectors. 9 plus 0 is 9. Negative 3 plus 12 will give you 9. Because you owe 3, you have. Settle, you have 9 left. So this is addition of vectors, which has also been discussed earlier on. Then you have here negative 2a. This time the scalar is negative. So we are going to say negative 2. What is the vector for a? 3, negative 1. So 3, negative 1. This times this will give you negative 6. Because negative times positive is negative. 2, 3, 6. Negative times negative is positive. So 2, 1, 2. So this becomes the answer for that. And this is how we do the multiplication of vectors, which also brings us to an end of vectors. If God permits, next week we'll look at the final part of vectors, which is position vectors. Then we'll come along with construction. We'll start with the basics, then we'll look at how to take the whole question on construction. Thank you for staying tuned, and please hit the subscription button for more videos. See you next week. Bye bye.